Hi Spring fans, welcome to another installment of Spring Tips. This week we've got something very exciting. We're going to talk about Liquibase. Liquibase is a database migration tool. It was born out of the need to bring database migration and database change management to the DevOps and cloud native era. The idea is that there should be a single funnel through which all changes in the architecture flow. And we talk about continuous delivery pipelines and continuous integration pipelines and so on. But so often that doesn't apply to the much more nuanced, much more stateful database change management systems and processes. The idea here is that whenever you deploy an application, you need to make sure that application has a schema that will work the way it's expecting it to work, and that you have a reliable way to take code that you've developed in a local machine and whose schema you've evolved and improved, and move that data and that change set into production. By using database change management systems, we get a log where we can sort of audit everything that's been done to the system. And we have an easy way to kind of version control it and look back and so on. So it's very nice to see what our system is expected to have and what it's expected to do, because it will set itself up. It will install its own schema. There are in Spring Boot a number of different database schema initializing things, right? Things like Hibernate's JPA support and DDL generation, Flyway, Liquibase, and of course ye old schema and data.sql files. I don't recommend that you use Liquibase, which is what we're going to look at today, with any of those other ones. In fact, you should go out of your way to disable all of them. But they can be very convenient. All right. We're going to need a database before we can get started using a database. So I've got a little script here. Thanks to the magic of containers and Docker, we can easily get an instance up against which we can write data and read data and so on. So here's a little script that I use. It has parameters for the name, the logical name of the container, which we can use for anything, I suppose, and also the port, because if you have more than one instance of Postgres running on the same machine, you're of course going to want to parameterize the port on which it runs, because otherwise you'll have a conflict. So this script runs the Docker image for Postgres in the background, in a detached way. So I'm going to create an instance called, let's say, A, right? And I'm going to call it 5400. That's the port. Okay, so now if I do docker ps minus A minus F name equals Postgres, you can see we've got that instance. And by the way, if you want to just remove that instance, you can get the container ID and then loop through it while readline do docker rmfl done, right? That'll destroy all the instances that you have. So filter name equals Postgres, none, right? So now we can rerun this, get that instance back. Okay, so we have our instance. We have a database against which we can work. Let's connect to it. Okay, so we have our shell. What I want to do is I want to connect to that instance. So the user is user. The host will be my max host and port, right? So MBT 2021 local P. The host is that, but the P is 5400, and the schema is user, and of course the password is PW, right? So there we are. There's my schema instance, my database instance. I'm logged in. I've got nothing going on there. It's obviously brand new, empty, but we're already good to go. We have a working SQL database with which we can work, and we have the ability to spin up more instances. All right, we have our sample database. Let's set up a bootstrap schema so that we have something with which to work. I've got a little file here called bootstrap.sql, and I'm just going to pipe that to my instance. So pg password equals pw psqlu is user h mbp 2021.local p5400 and user. All right. Now, if we log into the instance like this, we can see there's articles and comments. All right. So if we say select all from articles, you can see I've got 3 records there, and they in turn have some comments. We can see the sort of comments and the articles as a left join. So we can say select a.id as AID, c.id as CID, a.title, a.authored, c.content, comment from articles A, left join comments C on A.id equals C.article.id. Okay, so there you go. There's our, you can see we've got, all the rows are there from the left, which is the articles table, right? So we have all the articles, even if they have no comments, we have that. And so those records show up as nulls or as values with columns with no values in them. But we do see the information from the respective article. All right, our schema is set up. Let's just verify that everything is working as we expect. Remember, this is a left join, right? We've got articles that have 0 to n comments, and that makes it very easy to select everything. But we don't want to do a regular join because that will exclude things that have 0 records. I want every article to show up whether they have a comment or not. Okay, so I'm going to use a left join to guarantee that everything from the articles table shows up, even if there's no corresponding record or records in the comments table. So that looks like this. And what I get is the article IDs and the comment ID. So article ID is 3, comment ID is 1, article ID is 1, comment ID is 2, article ID is 1, comment ID is 3. So, there's, and then there's article ID 2, which has a null in the CID column because, again, there's nothing from the comments for that record. We can easily map those results into Java objects in our code. So let's go ahead and build a Spring Boot application that connects to this SQL database. We'll go here to the Spring Initializer as usual, and I'm going to build a new service using, we're just going to call this Liquibase, okay? Or as I like to call it, Liquibase. And we're going to add Liquibase in, we're going to add Spring Native in, we're going to add JDBC, the basic Spring Boot and Spring Framework JDBC support in, and of course we want Postgres and Lombok. And I think that's it. I think that'll do. So we're going to hit generate and open this up in our IDE. Let's create a new shell, go to the download directory, and open this up. Bear in mind that right now our first goal is just to keep things simple and connect to the database. So let's go to our build and disable Liquibase. We'll be right back. Obviously, we're going to use that a lot here today, but I just want to get rid of it for now because it doesn't buy us anything. Reload the project. And then we want to create an application that connects to the database and does some work with it. Well, in order to connect, it needs a username and password. So we'll say Spring data source URL, JDBC Postgres QL, MVP 2021.local 5400/user. The username is also user, and the password, as you can guess, is probably just user. Okay, that's the basic. Let's see if that works. All right, no problem so far. Now what I want to do is I want to connect and use the JDBC template to map the result sets into Java objects. So I will create an application runner that uses the row mapper, but I need to actually write that row mapper here first. So class article row mapper implements row mapper. And I'm going to map data into types of articles. Now, articles, are just very simple rows. So I'm going to use the very wonderful record syntax from Java 17. The article will have the ID, a title, the date that we authored it, and a list of comments. Okay? The date we can add like that. We have to write the comment type as well. And the comment has an ID and some text. Okay? Good. All right, there's our basic arrangement, our basic model. It's a one-to-many of articles to customers. All right, let's now flesh this out. We're going to have a cache, if you will, of longs to articles. Okay, articles, new concurrent hash map. And we're going to add the result. We're going to create the result out of the data and add it to the map, but only if it doesn't already exist, right? So we're going to say that the article ID is equal to article ID. Comment ID will be equal to comment ID. And the article itself is this.articles.compute if absent article ID. And we're going to just delegate this. Given an article ID, we're going to call another method called build that takes an article ID and it takes the result set. Okay. So we haven't built that method, but we can do that right here. All right. And it might throw an exception, who knows? So we'll use Lombok's very convenient sneaky throws. And if the comment ID is greater than 0, then we're going to say article.comments.add new comment. And it'll be comment ID on the left, of course, and get string comment on the right. All right. And finally, we're going to return articles. Now, this is going to return extra data, right? It's going to return as many articles as there are comments for that article. So if you have 3 articles, but you have 15 comments, you'll get 15 rows back. So we'll have to take care of that when we consume this data. But first, let's make sure we build the article ID correctly. The result set string for titles, rs.get date, authored, and a new array list. Good. All right, we've got our basic row mapper, and we've got our records. Let's go ahead and try them out in a standalone application runner. We'll say template.query, and here we're going to need a proper query, basically the one that we looked at earlier. So we'll actually use another wonderful feature, multi-line strings here. We'll say select c.id as comment ID, a.id as article ID, and then we want everything else, right? So c.comment, a.authored, a.title as comment, as authored, as title, from comments from articles A, left join comments C on a.id equals c.article ID. All right, that should be our SQL query. Let's use that with the JDBC template. We'll say query SQL new article row mapper, and that'll give us a list, which is good. It's already good, but like I said, it'll have as many comments as we have, not as many articles. So we need to dedupe that. Obviously, a hash set is purpose-built for this, and it works because we have the record, we have the identity, right? We have the identity of the type is implied by the components of the type. And in this case, records just give us that identity function for free. So given that, I'm going to log out the article. All right, let's see what we got. Let's run it. Ah, not bad. It worked. We have our articles, 1 and 2 and 3. And the first one has 2 comments, right? It's actually ordered here last in the output, but it's the first ID. It has 2 comments. You can see that here. This one only has 1 comment, and the middle one has no comment. All right, it's time to reintroduce Liquibase into our Maven build and see how we can integrate it with our Spring Boot application and our data management lifecycle. First things first, we'll uncomment out the Liquibase core dependency. Now, this could be the extent of our use of Liquibase. You could just use it as something that starts when Spring Boot starts up, right? It's something that validates that your database is as migrated as it needs to be to work correctly with your Spring Boot application. And that could be the extent of your use of Liquibase in Spring Boot. And if that's it, then that's fine. But you typically use Liquibase with something else, like a Maven plugin or the Liquibase command line tool or whatever. So we're going to also use the Maven plugin for Liquibase. To use it, you just go down to the plugin section and specify a plugin. Specify the group ID, org Liquibase, Liquibase core. The version is whatever the latest version is for you at the time of this writing. I'm using 450. The configuration is you're gonna point it to a property file, right? This property file is actually where most of the configuration for Liquibase lives. So source main resources liquibase.properties. All right, there we go. There's our liquibase.properties. Liquibase Maven plugin. We import that. And naturally, we need to create this file as well. So let's go here, source main resources, paste, and we're going to call this liquibase.properties. All right. Now, liquibase.properties is what the Maven plugin is going to use. These things can line up. You can do property placeholder, interpolation using Maven property replacement or whatever it's called these days, if you wanted to. But I find generally it's not too big a deal to maintain both the property files and obviously your production credentials have no business being anywhere near this code. They shouldn't be here at all. So that that's moot, right? That should be something that lives entirely in memory in the production environment behind lock and key, far, far away from you or your ability to even inadvertently cause destruction. So in this file, you create a few keys. These are not Spring Boot properties. These are just regular properties, just a regular properties file. So the URL against which you want to act is what we've been calling A this entire time. So local, it's MVP 2021.local/user. The username is user. The PW is PW. And the driver we want to use is org PostgreSQL driver. And the changelog file, this is arguably the most important part, is the file that contains the list or log of changes, right? And those files, there's a default format that Spring Boot will look for, but I think you should plan on overriding this anyway. This file, first of all, it can come in many different formats, right? It's a DSL that is available with varying levels of compatibility and support in regular just SQL, as JSON files, as YAML files, and as XML. If you Google this file format, if you Google changelogs for Liquibase, you'll find there's a lot of XML examples out there. However, I don't really like the XML format. I quite like being able to just look at my SQL code, and I'm not trying to run the same application across multiple different database tiers either. I don't mind being stuck on Postgres. It's a world-class database with some of the best compatibility and features of any database on the market, and it's Apache 2 licensed or similar, right? So it's fine, right? It's open source. So I'm not really trying to get any of the benefits that you get by having the indirection afforded to you by a meta model of your changes. I'd rather just express my changes. Life is hard enough. And so I'm going to use changelog.sql. And that's it for now. Now that'll actually do. I need to specify something similar in my Spring Boot application. So I'll say changelog equals class path. It's called db changelog and changelog.sql. Okay, now I have to create this changelog here. So changelog.sql, changelog.sql. Okay, there's my file. This should be a valid start. Let's see, this is a Liquibase formatted SQL. Okay, let's see if it works as a Spring Boot application. Yep, it seems to have worked just fine. That's great. Now, will this work as a Maven plugin? So let's open up the Liquibase properties and just review everything. Okay, wait, I forgot the port 5400 db changelog, right? Okay, now let's go to the terminal and run that Maven command, Maven Liquibase update. And I did that and it ran just fine. It prompted me there because I'm doing a migration against a non-local database. I'm doing in reality, this is my local machine. It's my Mac's host and port, but it thinks it's not 127.0.0 a local host. So therefore I should be warned. It's fine, right? This is a very convenient warning, but I wouldn't worry about it. Okay, so it's also working just fine there. Now, that said, I don't have anything here. I'd like to bootstrap that configuration, that schema, that change set with a state that's already in the database. So I'm going to use instead a generate changelog command for the Maven Liquibase plugin. So Maven Liquibase generate changelog, and then minus D Liquibase output changelog file equals source main resources db changelog generated .sql. Okay, when we did that, we see that it's actually captured our SQL tables and our data as changes, right? So here we go. I've got the create table for my articles. I've got the create table for comments, and I've got an alter table adding the foreign key for the articles, right? And that's all just done for me automatically. I've now got this. I can copy and paste it into here, and now I've got my own changelog, right? I've got the hard part was done automatically for me. Okay, so there's a couple things that we should care about when we define these change steps. The first thing is what conditions apply when we are creating this change set, right? It may not look at when you look at this pedestrian SQL script, but these comments are actually a special syntax. And Liquibase looks at this and says that everything between these two comments is meant to be one atomic block of change or mutation that happens on the database. And so you can group multiple related things together. And you can also specify certain attributes about the migration, about the change itself. One very convenient thing to specify is preconditions. So preconditions, and we want it to, when it fails, we just want to say, no, skip it basically. On fail, mark ran, and on error, mark ran. And then we want to specify some SQL checks. So precondition, SQL check. We're going to expect certain results to be true before we bother running this change set. So expected result is 0, and we're going to say select count from information schema tables where table name equals articles. Okay, so what we're doing there is we're saying don't bother running this unless this SQL query comes back true. It's an assertion, basically. We're saying I'm expecting that if I query the database itself and ask it what tables it has that are named articles, it should have no tables. Obviously, a more interesting query would also filter based on the current schema, but for a demo in a Docker container with only our data in it, this is fine. Okay, so we want to repeat that basic arrangement for the next two items as well. So here we want to say, don't create the table unless there is no table. So if there is a table, don't bother creating it, right? Okay, good. And then for this last one, we want to make sure, actually, I quite like the idea that this is just one atomic thing. So those things belong together. So let's reset everything here. Okay. Okay, good. So we've got our preconditions. Let's go ahead and run this one. And we'll say Maven Liquibase update. Good. It's worked. We can go back to this. Minus D. Okay, good. Articles. There we are. There's all of our data. Comments. Fantastic. There it is. Now, what I want to do is I want to also add the SQL data that we had in there from our bootstrap. So I'll create yet another change set manually. Change set JLong and data. And I'm going to insert some sample data. Alrighty. Now, of course, for this to work, I also have some preconditions. So I will say select count from articles, right? I'm expecting there to be no data in the article table. Otherwise, what's the point of inserting the data into the article table. So this is pretty easy to write by ourselves. Okay, now let's try this one more time. Good. If we go back to the shell, select all from articles. Good. There's the 3 records. Let's try running this again. And you can see it succeeded even though it had conflicts and we still only have 3 records. Okay. So this is very convenient. We were able to write changes that only get applied, or that even if they fail, we don't care. We can just keep moving on, making it so that we'll get to the right state eventually, right? This is a nice language and database agnostic way of doing this. Obviously, there's little things you can do in various implementations of the SQL spec that allow you to say, oh, okay, create this, but only if it doesn't exist. So create table if not exists foo, right? Where foo is a table, and if it doesn't exist, it gets created. If it does, then it just gets left alone. You just this kind of stuff is there's a lot of these like weird syntaxes that are different, right? The idea of an upsert is very different from the way you do a create table if it doesn't exist, or alter, alterations, whatever. But this is nice because you have this mechanism here in your change management tool, and it doesn't matter what your syntax is for your particular database. You can just use this mechanism and it gets you the same result, okay? All right, so we've manually added a change set, and you can actually see that change set here. You can see select all from database change log, and you can see that it's run these various scripts, and you can see what steps happened and all that. You even have a checksum of the delta, right? So that's very convenient, right? We have a way of seeing what has been changed in the system. Okay, let's reset everything again. So drop table, database change log, database change log lock, articles, comments. Okay, so we have nothing there. Now I want to rerun these changes, but I also want to provide a way to roll back. This is one of the most powerful aspects of Liquibase, is this mechanism that allows you to specify how to systematically undo a change. Okay, so we're going to introduce the rollback stanza, and basically you can just put the opposite of what you've just done. So I've created a table. The rollback for that would be to drop table articles, comma, comments, right? Articles. There you go. Good. So what about that one? What about this? This is, well, that'll get, the rollback here is just drop table comments. Okay. Or we can do drop table articles cascade. Maybe that's more appropriate. And then drop table comments. And then here, we're adding some data. So the rollback would just be to truncate the data, wouldn't it? So truncate articles, comments. Good. So now we have a way to systematically roll back the changes. All right, let's go ahead and run the Maven plugin one more time. Good. It's now made the changes to our system. So select all from articles. There's our data. The nice thing about this is that maybe I want to roll back one of the changes now. Okay, so one of the last things I did was I created some sample data. Maybe I didn't mean to do that. Maybe this doesn't need to be here. So I want to roll back the last thing, which is the addition of that data. No problem. Maven Liquibase rollback d Liquibase dot rollback count equals, let's say, 1. And now if I select all from articles, there's nothing in it. So I'm able to systematically roll back the changes. So we've looked at how we can use Liquibase to, in a consistent way, add code to our schema before the application starts up. We've looked at how we can use Liquibase to roll back changes in a well-understood manner. We've looked at how Liquibase allows us to version control changes to the SQL database, which have to go through the same regression harness and the same continuous integration pipeline and continuous delivery pipeline as everything else in the system. We've also seen how this allows us to ensure that our application is in the correct state. but we have to make sure that our code doesn't use it while it's being initialized. This gets us to yet another very convenient aspect of the integration with Liquibase and Spring Boot, which is that you can have components that need a fully initialized data source initialized only after that data source has been initialized. So we can do that by annotating our bean or our component class itself. So it's going to be called depends on database initialization. And Spring Boot will see that this bean should only be run after the data source is fully initialized. So now if I run this on my local machine, there we go. It worked. Now, of course, it worked. It would have worked last time as well. But sometimes it doesn't. Sometimes you have something that, because this application runner gets run late anyway. But if you have other components that need to run, they have life cycles that need to run earlier, but you want them to run after the database is initialized, this can help with that. The integration with Liquibase and Spring Boot is really, really quite sophisticated. Spring Boot has a whole host of different database initialization options, including Liquibase, Flyway, and of course, ye old Schema.sql and data.sql, which get run when the application starts up. All of these are they have a certain kind of role in a Spring Boot application, and they all get run before beans that have this annotation. You can configure custom implementations of that if you like, but typically people just tend to use one of those three. Spring Boot has a whole host of implementations, including, but not limited to, Flyway, Liquibase, the ye old Schema.sql and data.sql, and Hibernate JPA data source DDL generation that all need to run before beans that have this annotation. And they have a certain role within Spring Boot. You can, of course, define your own custom implementation of the type that it's looking for, if you like. But the point is, it's a well-understood type in Spring Boot, and there's a well-understood life cycle for this. Spring Boot's integration with Liquibase in particular is also very rich. One of my favorite things, especially for tests, is to use the Liquibase drop first equals true. So this will recreate it'll drop and then recreate the database schema. And you can put this in a test, in a unit test. So for example, source test Java, and up here you can say properties equals true, right? So when this runs, it'll clear the schema for you and then reset it, which is, maybe that's what you want for an integration test. Maybe it's not, I don't know, but the point is it's just very convenient that you can. So far, we've moved pretty quickly, and I've only made small changes here and there. But realistically, I'm probably going to hack on the database and the schema with the DBA, and we're going to arrive at a whole bunch of changes, and I'll want those to all be accounted for. And you tend to iterate, right? It's very easy to just sort of mold your schema into the shape you need it, and then you want to codify that once you've captured it. One convenient feature of Liquibase is that it can capture a diff of your two different databases. And this can be very convenient if you want to point Liquibase to an instance of your old production environment, or a copy of your production environment, and point it to your new development environment and have it generate a delta capturing the difference between the two. Let's use the Maven Liquibase plugin to do that for me. I'm going to create a script here because it requires a few parameters and it gets tedious to write it all out on the shell. So I'm going to say diff.sh. Okay, we're going to use the Maven Liquibase diff command. But in order for this to work, we need to have two different database environments. This is why it's very convenient that we have that little script that we created earlier. So we're going to create Postgres desktop, Postgres B5500. Okay, so now we have two different Postgres instances, and we want our application to spin up and talk to that one as well. So both should be in the same place. Okay, there we go. So now if we logged in to that instance, 5500, you can see that we've got that schema as well. So select all from articles, etc. Okay, so now we've got the same exact data in both. So now we have two environments, 5400 and 5500. 5500 is our new development environment. All right, let's add a new column to the comments table. Alter table comments, add column, moderated, bool, not null, default is false. Okay, There we go. So now if we look at comments, it has an extra column that we don't have in 5400, our production environment. What I want to do is I want to capture that as a change set. We'll go to the command line. Okay, so we're going to use the Maven Liquibase Diff command. So Maven Liquibase Diff, and then we have some information that we need to specify. So -d liquibase.diff change log file equals diff.sql. D liquibase.reference URL equals JDBC PostgreSQL localhost user, and the port, of course, is 5500. Reference username equals user. Reference password equals PW. We have the password, and then we're going to specify liquibase.reference driver equals org postgresql.driver. All right, let's run this on the command line now. Okay, so we should have a file here called diff.sql, and there it is. That's a change set, so we can just take that, add that to this, and we don't have to figure out what has happened. It'll just automatically do it for us. And of course, here would be a good time to specify a rollback. So you could say, truncate or drop alter table comments, drop column moderated. And of course, you could also specify some preconditions to make sure that that column is not already there. And if it is, to not bother it, right? Okay, so one of the things I want to do is I want to make this work in a GraalVM native image context. If you know me, you know I love GraalVM. So I'm going to build a little hints file. Right, I'm just going to create a new package here called nativex or something like that, and I'll create a new class called Liquibase native configuration. And I'm not going to sit here and make you watch the whole thing. I'm just going to copy and paste a file that I've already written, but whose source code you can of course find on the GitHub repository for this very project, github.com/spring-tips/Liquibase. And there it is. So let me see, I've called it native configuration. Here's the original, it's called hints. Easy enough to fix. Now we need to register this as a in the Spring service loader, this spring.factories file. So let's go here, create a new file called spring.factories, and I'm going to register the configuration type, copy reference here, and then the actual type here. Okay, that's it. And with that, I can go to my build and let's run it. Maven -p native d skip tests equals true, clean package. Now this will take about a minute, maybe a minute and a half or something like that. So we'll let it do its thing, and then I'll see you on the other side of the jump. All right, the build is completed. Let's try it out. So we'll go to the target directory and then run it. And there we go. It ran. It took about 131 milliseconds. And that is, of course, all to do with Liquibase. It's doing a lot of deterministic sort of state checking to make sure that our SQL database has initialized itself correctly. And you can see in the logs there where it's, logging out what it's trying to do. But of course, we get to the very bottom of the program, and there's all of our information. There's everything that we were trying to do, confirmed by the results.